In this lesson you will learn about the ATR42 fuel system and indications. The ATR42 fuel system is equipped with two tanks, each fitted with one feeder compartment and one vent surge tank. The vent system ensures venting in the wings and between the two tanks. This unit also discusses each tank's fuel quantity indicating system. And finally, the automatic and manual refueling and defueling process. First, we will look at the fuel storage. As you can see, the fuel is stored in two tanks. The total capacity of each tank is 2,868 litres or 2,250 kilograms with a density of 0.785. Each tank has a feeder compartment and a vent surge tank. Now click on the right-hand feeder compartment and the right-hand vent surge tank for more information. The feeder compartment feeds fuel into the main engine pump system and has a capacity of 200 litres. Note that only the left feeder compartment's fuel temperature is measured and displayed on the flight deck. The vent surge tank maintains a constant pressure in the tanks as the fuel is used. The vent surge tank's capacity is 100 litres, which allows for thermal expansion. Each tank has two access doors, which are located on the upper wing skin. The outside access doors are equipped with a gravity filling cap. The tanks are equipped with water drainage at the low point of each tank. The vent system takes air from the NACA inlet, which goes into the vent surge tank. Air then passes into the vent line and into the tank via the sniffle valve. The air pressure maintains positive pressure in the tank as the fuel level goes down. The vent system also provides protection against any fuel spillage during refueling. Any spilled fuel is sucked into the main reservoir after the aircraft takes off. Next, we will consider the wing center box located between the two parts of the wing. The box does not store any fuel. Two fuel pipes in the wing center box carry fuel for engine crossfeed and tank refueling. Venting the wing center box prevents fuel vapor concentration. The wing center box also contains an air intake and two air outlets. Which of the highlighted areas do you think is the air intake line? What is the purpose of the reservoir venting system? Now let's test your memory. Match the labels to the correct area of the aircraft. In this part of the lesson, we will describe the engine feed system. Each engine is fed or supplied by its feeder compartment. The feeder compartment is always full to ensure the engine is fed enough fuel, even with negative or lateral load factors. The fuel system consists of the following components: the electric pump, the low pressure switch, the low pressure valve, the hydromechanical unit, HMU, the motive flow valve, the engine feed jet pump and its pressure switch, and the feeder jet pump. The electric pump is mainly used for engine start. It supplies fuel through the low-pressure valve to the HMU and the feeder jet pump to ensure refilling of the feeder compartment, to the motive flow valve and the engine feed jet pump when the engine is started, and finally to the pressure switch, which at 7 psi signals the electric pump to shut down. When the electric pump push button is depressed and the engine has started, the engine's jet pump takes over from the electric pump and supplies the HMU, and continues the fuel supply to the feeder jet pump. To summarize, in normal operation the electric pump is used for engine starting. After engine start, the engine jet pump takes over. However, in the case of an abnormal operation, where the engine jet feed pump drops below 7 psi, the electric pump is automatically activated. What pressure triggers the operation of the electric pump? Each electric pump can supply one engine during a whole flight envelope. Each engine jet feed pump can supply both engines during a complete flight envelope. Note that this is not possible during takeoff. The crossfeed valve allows crossfeed of the engine. To start crossfeeding of the fuel, you select the crossfeed push button. Do this now. Crossfeed allows both engines to be fed from one tank. In the case of single engine operation, crossfeed allows feeding from either tank. Whatever the reason is for using cross-feed, the maximum allowed fuel imbalance between the tanks is 550 kilograms. Match the labels to the highlighted components. What is the maximum allowed fuel imbalance? Is it possible to feed both engines from tank 1? In this section we will consider how fuel is measured. The fuel in each tank is measured by two totally independent but identical systems. Fuel mass is measured by 5 capacitance probes in each tank. One is located in the feeder compartment and 4 in the fuel tank. As you can see here, there are none in the vent surge tank. The capacitance probe's reading is shown on the fuel quantity indicators. Remember that the fuel in each tank is measured by two totally independent systems. The accuracy of the total fuel indication on the ground, with the aircraft attitude plus or minus 2 degrees of pitch and plus or minus 1 degree of roll, is plus or minus 1% of full scale near zero, and plus or minus 3% of full scale at full level. There are two ways to read the fuel quantity. One way is by the fuel quantity panel, which is located in the flight deck. The other way is by the two dipsticks located in each wing, which are used during a fuel quantity indication failure on the ground. Next, we will see how the dipsticks are read. The dipsticks, or magnetic level indicators, as they are sometimes called, are located on the lower wing skin, one by the vent surge tank, and one by the feeder compartment. Now click on the left-hand dipstick on the aircraft. The dipstick is measured by a scale as shown in the photograph. The scale must be converted to litres by using a special chart. The fuel quantity depends on the aircraft's attitude and the fuel density. You use the carburant chart to find the fuel quantity in each tank. Take the reading from the external dipstick. Take the reading from the internal dipstick. The meeting point indicates the fuel quantity in litres as shown here. With the dipstick values as shown, select the correct fuel quantity. If the external dipstick reads 0, then the chart is read differently. You must compare the aircraft roll reading with the internal dipstick reading. This is located on the roll angle indicator on the left landing gear fairing. Where the lines meet shows the amount of fuel in the tank. The aircraft can be refueled automatically, manually, or by gravity. The automatic refueling system consists of the refuel-defuel panel, information from the fuel quantity indicating system, and a single refuel-defuel port connected to two refueling valves, which are electrically controlled by the panel and are actuated by fuel pressure. Click on the refuel-defuel port on the aircraft for more information. Each fuel valve has a manual latch, which is used if the valve cannot be opened electrically. Pulling the latches lets fuel flow to the valves. Fuel then flows from the valve outlets through pipes to diffusers. The diffusers let the fuel enter the tanks without turbulence. The fuel flows through a restrictor located in the right-hand pipe. This ensures balanced refueling in both tanks. Note that the maximum refueling pressure is 50 psi, 3.5 bars. Before looking at the refueling panel in more detail, try this question. Where is the refueling port? The refueling panel is located on the right-hand main landing gear fairing. The best way to explain the refueling panel is to operate a refueling. Click on each of the highlighted areas of the panel in sequence for more information. The mode selector switches have three positions. Off indicates the refuel valves are closed and the switches are not activated. The refuel position indicates that automatic or manual refueling may be used, and the defuel position indicates that manual defueling is possible. The fuel quantity test push button, when pushed, displays 8s on the fuel quantity indicators on the refueling panel and on the flight deck. It shuts the refuel valves as if the tanks were at their maximum refuel level and activates the CCAS. The selected quantity wheels allow the setting of the required fuel quantity. The fuel quantity indicators show the fuel quantity as shown on the flight deck. This information is used as a reference to stop the refueling operation. The refuel valve switches have 3 positions: shut, which indicates the valves are selected closed; open, which indicates the valves are selected open; and norm, meaning the valves are controlled by the automatic fueling logic. In this position, the valves close automatically when the pre-selected fuel level is reached. Now you may refuel. First, click on the selected quantity wheel to select the required amount of fuel, then select Refuel. The refuel valve position lights illuminate when the refuel valves are open. The refueling sequence stops when the fuel quantity reaches the pre-selected quantity, and the light goes off. In case of a problem in the automation sequence, each tank is equipped with a high-level sensor. This light illuminates when the fuel level reaches the sensor and the refueling valve closes. Note that the sensor is used to warn against overfilling the fuel tank, not to warn against going over the selected fuel quantity. Now you may start the defueling process. The defueling sequence is a manual control sequence. It uses suction. The maximum pressure for defueling is 11 psi, or 0.77 bars. The main landing gear light switch has 2 positions. The switch activates the light located on the main landing gear fairing. What is indicated by the illumination of the refuel valves? Note that refueling is also possible using gravity through the gravity filling ports located on each wing. The fuel control panel is located on the overhead panel and consists of the electric pump push button, the feed low pressure light, the low pressure valve indicator, and the crossfeed push button. Now click on the push buttons and indicators for more information. When the electric pump push button is off, no power is supplied to the pump and the motive flow valve is not allowed to open. When the electric pump is on, the pump is electrically supplied. The motive valve then opens at engine start. In order for the electric pump to become blank, the engine must be started to supply the engine feed jet pump via the motive flow valve. When the pressure sensor detects a pressure of 7 psi, the electric pump stops and the run light extinguishes. The low-pressure valves are controlled by their corresponding fire handle. The low-pressure valves are indicated by a cross line, meaning the valve is closed, an in line, meaning the valve is opened, and a blank indication, meaning the transient phase between an opening or closing valve. The fire handle controls the low-pressure valve and acts on two electrical motors. One is supplied by the DC emergency bus and the other by the DC bus. If the feed low-pressure light shows amber and the CCAS is activated, this indicates that the fuel pressure at the low-pressure valve has dropped below 5 psi. This is caused by either a pump failure or fuel starvation. The crossfeed push button has a crossed line when closed. When the flow bar is in line, the crossfeed valve is open. Which push button indicates an open crossfeed valve? Can you remember how the low-pressure valves are activated? Which push button indicates an open crossfeed valve? The fuel quantity panel is located on the center instrument panel as shown here. It has two displays, one for each tank. Now click on the test button and note the indications. In a fuel quantity panel test, the fuel tank indicators illuminate with 8s. Both low-level lights illuminate and the CCAS is activated. The low-level lights illuminate when the fuel quantity reaches 160 kilograms. The electric pump is activated simultaneously, which is shown by the illumination of the run light in the electric pump push buttons. The fuel crossfeed light is located on the center instrument panel and illuminates in line when the crossfeed valve is open. The fuel tank temperature indicator is located on the center instrument panel and shows the fuel temperature and shows the reading from a temperature measuring device in the left-hand feeder compartment. The fuel feeder indicators are located on the maintenance panel as shown here. There is a sensor in each feeder tank to detect fuel levels. If the sensor does not detect the feeder tank is full 10 minutes after the feeder jet pump has started, the built-in test equipment, BITE, light illuminates. Before ending the lesson, try this question. Approximately how long do tanks take to fill after the jet feeder pump starts? When do you think the low-level lights illuminate? Can you remember from where the tank fuel temperature indicator obtains its information? Where are the fuel feeder indicators? The system operation lesson covers the operation of the fuel test and the fuel crossfeed. Now we will go through the step-by-step procedure for the fuel test. Start by clicking on the left fuel pump push button. The first step involves selecting the left fuel pump on. This extinguishes the off light, illuminates the run light, and extinguishes the feed low pressure indicator. For the second step, click on the crossfeed push button. Selecting the crossfeed push button on illuminates the flow bar in the crossfeed push button, extinguishes the right-hand feed low pressure indicator, and extinguishes the fuel light on the CAP. For the third step, click on the right fuel pump push button. Selecting the right-hand fuel pump push button to on extinguishes the off light and illuminates the run light. For the fourth step, click again on the left-hand pump push button. Selecting the left-hand fuel pump again illuminates the off light and extinguishes the run light. For the fifth step, click again on the crossfeed push button. Selecting the crossfeed push button to the closed position illuminates the vertical bar, illuminates the feed low pressure indicator, and activates the CCAS. For the sixth and final step, click on the right-hand fuel pump push button. Selecting the right fuel pump to off illuminates the right-hand feed low pressure indicator, illuminates the off light, and extinguishes the run light. The fuel test is now complete. The aircraft conditions are as follows. Both engines are running, but the right-hand tank has more fuel than the left-hand. Click on the crossfeed push button to start the crossfeed procedure. When the crossfeed valve is opened, the flow bar illuminates on line and both run lights illuminate. Now click on the left-hand pump push button. By turning the left-hand pump to off, the off light illuminates and the run light extinguishes. This allows the right-hand tank to feed both engines until the desired quantity is reached. Now click on the left pump push button and then the crossfeed push button to complete the procedure. The crossfeed procedure is now complete and both engines are now being fed by their respective tanks. Why would you use the crossfeed push button? The non-normal operation lesson looks at what to do in case of feed low pressure and fuel low level conditions. In flight, low fuel pressure is indicated by a master caution, illumination of the feed low pressure indicator, illumination of the fuel light on the CAP, and the illumination of the run light on the affected side. In this example, the run light indicates that the electric pump is running. The feed low pressure light indicates that not enough pressure is supplying the engine. In this case, the checklist must be consulted for further action. During flight, a low fuel level has been detected. This is indicated as follows. The master caution is triggered. The fuel light illuminates on the CAP. The low-level light illuminates on the affected side. 160 kilograms is shown on the affected side, and the run light illuminates on the affected side. The run light illuminated on the affected pump push button indicates the electric pump has been switched on. Before ending the lesson, try these questions. What procedures must you follow if the feed low pressure light illuminates? A fuel low level has been detected and the run light has illuminated on the right-hand pump push button. What does the run light indicate?